Hi, welcome Abhishek. So, in this mock interview round, we are taking Agentic AI related evaluations for a 6 years experienced forward deployed engineer at an organization like OpenAI. So, you will be presented with a question and you have to construct the answer in the respective answer framework on which we were practicing. So, you have to address all those touch points and then we'll evaluate, the performance. So let's get started. So here is the first question.
How would you design and evaluate an agentic AI system for a customer-facing deployment with tool use, memory, and human escalation?
Okay. So for this particular scenario where, I have to design and evaluate an agentic AI system, I will be doing this particular task in in set of layer. I'll be designing the whole task in set of layer, let's say 4 or 5 layer. The first layer would be the orchestration layer. The land graph would be used as a state machine. Each customer interaction would be a graph node. So the sequence would be like intake, then tool execution, then response, and then escalation check. So conditional edges, would be in place to decide the routing based on the confidence score and the intent classification of the initial query. The tool I will be using, as I used in my recent project, I'll be focusing heavily on the middleware because it would be like an optimization for, all the APIs cross connection. So I'll be using MCP as the middleware. Every external tool like, order lookup, CRM, knowledge base, you know, it would be an MCP server exposing a standard interface. So, there won't be any issue in communication or due to schema difference. The agent would call tools without, knowing what is underneath. And the new tools, uh, which are, usually the MCP server, so the orchestration would never change. It would remain stable throughout the journey. For memory part, uh, so it need to be divided, I would say, into two layer at least. So there has to be a short term, which is in graph state, like the conversation turn tool result within the session, and there has to be a long term, which would be a in the vector store on any of the vector DB, storing the user preference and past interaction in let's say with compression, and it can be retrieved at session start via rack. So the agent has context before even the first message hit. For human escalation, interrupt node can be added with few conditions within the lang graph because lang graph has this functionality. Suppose if confidence is below threshold or there is a negative sentiment detected or there is an explicit user request, so which is beyond the application or let's say it is not ethical, so it can be flagged. So it would this it would package the full session context and hand off to the human agent with zero re uh, zero explanation required. And the human can also push the session back into the graph after intervening or doing the necessary check. For evaluation, it has to be done on the standard metrics for any software or any AI system. One would be the tool accuracy because it is an agentic workflow. So definitely there would be multiple tool call based on the prompt. The escalation precision, whether our system is able to flag it or not to the system. What is the recall? I mean the recall score and the task completion rate. So I would run a shadow mode first, and then agent would run silently alongside human before going live. So yeah, that's how I'll be handling.
Okay, good. Let's get to the next one.
In a live customer deployment, how would you detect and mitigate tool selection failures in an agentic AI system without degrading user experience?
Okay, so for this, like tool select detection and mitigation of tool selection failure, and that too in a live customer deployment. So the failure would definitely fall in few category. We need to categorize first what kind of failure it would be. One would be the wrong tool selection. The initial tool selection is wrong itself, or suppose if the right tool is called, but it is called with bad prompt or bad parameter. So both of these need to be handled in a very different manner. So in order to handle this, right, there has to be some detection layer mm, for this problem statement. So we have to look for few signals. The first or the initial would be the structured output validation. Every tool call must match a schema before the execution. So it can be done via Pydantic or similar thing. So if the LLM output a malformed call, that's caught before it hit the tool, because anyway it is going to fail and it would silently fail. Second would be the tool result confidence scoring. So if the results come back, it's come back empty, null, or with some error code, the graph flag it as a suspect call. And then we could add this log for every tool call with a with a reasoning trace in some kind of cloud logging or file system level logging, and run a asynchronous evaluator that check whether the tool chosen is actually matched the user intent or not. uh, Mitigation part, uh, also this has to be done into this mitigation problem can be solved in various layers. So first to because here the because it is a live customer deployment, so the major concern would be we should not degrade the UX. If we are touching, or if we are doing something, suppose we say, okay, the issue has been resolved. However, the UX doesn't look good, and that person is a non-technical person. So they would think like the system has broken completely, and we just not able to understand. So I would handle this in few layer. The first would be, I would retry with reprompting. So, if tool fail, the LangGraph node retries once with an explicit hint about which tool to use and why. The user won't see this anything at its end, so it would be like immediate, the reprompting logic. Second, definitely there has to be a fallback, and it has to be a graceful. So if retry fail, the agent fall back to the safe default. This safe default, either it could be a clarifying question to the user, or it could be a broader set of tools. The the you know, the user experience would stay conversational in nature. It won't see any hard error at the front end or at the UX side. At last, if suppose if both fail, then it has to be escalated to human, but with full context, so so that the handoff would be seamless. uh there has to be one observability thing need to be added. So, I would track the tool selection accuracy as a live metric, and it has to be embedded in the UX also, so that user could also see. So if it drops below the threshold, so that's an automated alert. So in production, there would be a shadow evaluator running in backend along with the backend system, and a second LLM call, the it would independently score whether the tool selection made sense or locked for some for offline review. So here in a nutshell, the key logic would be, fail silently where possible because it's a live demonstration, and fail gracefully where it is not, so that at least we should be having some alibi to the customer, like what is happening and what we can do in the next iteration. And definitely never let the infrastructure error surface because it would be confusing the non-technical mm, end customer.
Okay. Okay, great. Let's get to the next one.
How would you evaluate an agentic AI pilot's readiness for production across reliability, safety, latency, and business impact in a forward deployed customer environment?
Okay, so as earlier, for this question also, I would be evaluating it across multiple dimensions before recommending a production go live. So the first one would be for any engineering system or any AI system would be the reliability of system, whether the output of the system is reliable or not, depending upon mm, the business imperative and the business use case of the client. So I would run a pilot against, let's say a golden test set with suppose, some real customer queries covering edge cases or all kind of cases, mm, a high frequency intent and a known failure mode, all the things embedded in these queries. So what I'm looking would be for a task completion rate beyond 80% or 85%. And the tool call success rate has to be beyond 90% or somewhere near. And there has to be a error recovery rate. So how often does the agent self correct without human help? And if these three threshold hold, so definitely we can mark it as reliable. Because anyway, for production the metric would be different, but at least for initial discussion, this would be enough. Second would be the safety of the system. So safety, what I mean to say, there has to be a guardrail audit in place. So we need to check whether the agent ever hallucinate the tool output, or it fabricate the customer data or take irreversible action without confirmation. So if I would specifically test the adversarial input, like prompt injection or out of scope request or ambiguous edge cases, uh, so that I would be doing here. Post this, there has to be some escalation, the human escalation calibration. So where whether the agent escalating the right things or not. So I would I want precision and recall both has to be beyond 90% for escalation decision. Under escalating in a customer facing system would be a business risk, but here even if it if it provides score below 90%, we would be having at least a talking point to the customer where we can go ahead for improvement on the next iteration. The as the third would be the latency, because anyway at the end of the day we would be uh, helping any business, so there has to be some threshold of the response time from the agent. So we would be adding the P50 and P95 response time. For customer facing, P95 must be under at least 2 or 3 seconds for end to end, including tool call. If the tool call chains are slow, then I would look for parallelizing the independent tool call in the lang graph, or go for some kind of caching for the tool result, depending upon how much cost the project can handle. The last would be, yes, the default engineering question with the business impact, whether all this engineering work solve the uh, actual business problem or help the actual business problem. So I would measure a few things like the containment rate, like how many sessions the agent resolve without the human handoff. Some we need to obviously we need to compare some delta to the baseline. So let's say if suppose the current demonstration is baseline, so we can say, next in the next iteration we could measure the delta and we could share the report. We need to have we can add one cost agent. So like, cost per resolution versus human baseline, or cost for using one agent. So that metric can be added. So if the containment rate is good, or and the cost per resolution is lower, so that would be, that would be enough for the green light, at least for next iteration or going live. So using all these dimensions, if all these this pass, or at least they are good enough, so we can, I would be telling the customer, it's a green light at the engineering side, and we can go ahead with their feedback.
Okay. Let's get to the next one.
A customer's agentic AI passes offline evals but fails in production. How would you localize root causes and redesign the evaluation loop?
Okay. Mhm. Okay, it is failing in production, and so if the offline evals pass, because of test set, it doesn't reflect the production reality or the real world data set. So my first instinct would be, not to mix the model. It would be to find the gap between what we tested and what production actually looks like. So where is the gap? So step one, or the initial thing, would be I would try to localize the failure. I would pull the production traces from the log and would try to segment by the failure type or by the failure code. So the segment bucket would be, let's say, the wrong tool selection, correct tool but wrong output, or the correct output but the end result is dissatisfied. So each bucket points to a different root cause. It could be a model reasoning failure, or tool integration failure, or expectation mismatch. Post this, I would try to find, where is the distribution gap, or what is the distribution gap. So I would be comparing the offline evaluation data set with the production query distribution. So almost always, you would find that the production query has pattern edge cases that weren't in the initial eval set. So it could be, the ambiguous intent or something, that breaks the agent that passed clean eval. Uh, if the eval, at the last stage, I'd be going for fixing the evaluation loop. So this this would be the key insight. I would move from static evaluation set to a dynamic one. So every production failure gets automatically flagged and reviewed and added to the eval set, let's say within a set time period. So it would be like a continuous training thing, or up to date thing. And I would also add an online evaluator, like LLM as judge, running asynchronously on every production session. So it would be like us, it would be scoring the tool selection response quality. So now, after this, the evaluation or the eval loop would be continuous, not one time gate. So it would be continuously improving, continuously running. And we can also, I mean, as always, we can have a shadow testing before any fix go live. So once everything is redesigned, the eval loop, and we have patched the agent. So there has to be a new version run in shadow mode alongside production for at least some time, 1 day, 2 day, or whatever, before cutoff. And shadow shadow mode mean obviously zero impact. So whatever would be the result, I'd be communicating the same to the customer. Like the offline evals are necessary condition for production, not the sufficient one, and the evaluation loop must be alive and connected to production data all the time. So yeah, that's how I would be handling this situation.
Okay, sure. Let's get to the next one.
For a high-stakes customer workflow, how would you design online evals and guardrails for an agentic AI system after production launch?
Mhm. Okay. Okay, it's an design online eval and guardrail. Mm, so, if it is in high stake workflow, then uh, I would be designing the online eval and guardrail as two distinct entities, not clubbed together, but it would be a connected system running in production all the time. So for online eval, uh, there would be few layers. The first one would be LLM as judge, running asynchronously on every completed session. It would score the tool selection, correctness, response faithfulness, or the goal completion. So here asynchronous mean there would be zero latency impact on the user. Uh, and the result would be streamed into a dashboard, whatever the UX dashboard we are having. The second, we can have a metric layer. So I would track the signals in real time, like task completion, escalation rate, be tool error rate, or session abandonment, if it is, uh, you know, and if any metric move more than if we are beyond a selected standard deviation from the baseline, so I would get an automated alert before the customer does. So this functionality would be embedded. The third would be human spot checking. Like for high stake workflow specifically, I would randomly sample, let's say, 2% of the session for human review, regardless of whether the automated eval flags them or not. So this would catch this subtle error, technically correct but context contextually wrong responses. So that's what the evals would miss, or the automated system would miss. For guardrails, uh, you know, it would be added uh, for like a gate for the answer, which would be served to the user. So it would be before that. So it would be having few layers. There has to be an input guardrail. Every user message is classified before the agents would see. Uh, the prompt injection attempts and out of scope requests. And if there is some PII, personally identifiable data here, so it shouldn't be processed. So all would be caught at the gate. Then there would be an output guardrail. Every agent response is validated before delivery. So let's take the example of BFSI where I work. So for, let's say, for financial workflow specifically, I would have a rule based checker, like no agent can confirm a transaction above a threshold without a human confirmation step. Then there has to be an action guardrail also, like irreversible action, like deleting a record, or submitting some form, or changing something at the database level. So that would require an explicit interrupt node in the language. The agent must pause or get either user confirmation or human approval before executing. And the last would be connecting both guardrail and online eval. So when online eval flags a degradation, the guardrail would tighten up automatically because eval would send message to the guardrail. So if tool error rate spikes, the system drops into more conservative mode, higher escalation threshold. There would be more confirmation step to the human until the issue is diagnosed. So it would be like closed feedback loop. Here, the online eval would tell you when system is drifting, and guardrail would ensure drift never becomes a damage. You know. Yeah, that's how I would be handling the situation.
Okay, great.